Welcome guys in this session. Today we are going to discuss about the 4G and 5G and difference between the 4G and 5G communication system. So in the content section, firstly we will discuss about the 4G and its components. Then we will discuss about the 5G and its some components, and after that we will briefly discuss about the difference between the 4G and 5G. We also compare the 4G and 5G with 3G in some parts. So let's move to the next slide. Here firstly we will discuss about the 4G and its some components. So first of all, what is 4G? So basically 4G is the fourth generation of the mobile network communication system. So it is the long-term evolution LTE system. So it has used the voice calling over the digitally over the communication system, VoLTE system. So voice over the LTE that we are using in the Geo 4G. So it improved the services of the 3G, and it has also improved the some limitations of the 3G. As an example, while we are using the 3G, so in the 3G there is a limitation in the services like the video streaming, online video streaming. So there is a lot of buffering there, and on that services we have improved in the 4G, and the speeds that are in the 3G, that is a 144 kbp per second, but in the 4G this is improved, and other some services we have also improved in the 4G communication system. So next component we have, and the 4G is the OFDM system used, but in the 3G that is used in the CDMA, code division multiple access, that is used in the 3G, but in the 4G that is the OFDM system is used, orthogonal frequency division multiplexing system. So in the 4G OFDM there is the carrier signal is divided in the sub parts. So in the 4G on the base station mounted total number of the 64 antennas, so there are the 64 subcarriers, and these are subcarriers behaves like a pilot signal to the pilot signals that are useful to estimate the channel estimation in the uplink and downlink system. So here the question is arising, what is uplink and what is downlink communication? So as we all know, the uplink communication system is the communication from mobile to base station, that is the uplink communication, and from base station to mobile, that is downlink communication. And MIMO system is used in the 4G communication system. MIMO is the multiple input and multiple output system, where the multiple number of the inputs and multiple number of the outputs are communicating each other from multiple number of the users and multiple number of the base stations that are communicating each other at same time. So if we consider an example of MIMO, suppose in the 3G we are transmitting a message, and it takes the 10 minutes to reach the destination. So with the help of this MIMO concept, every antenna is connected to the every user. So with the help of this MIMO, so it takes the signal that are taking the 10 minutes to reach the destination. No, in the MIMO it takes only 1 or 2 minutes to reach the destination. So it is 10 times faster than 3G. So the bandwidth that is used in the 4G, that is 200 Mbps. So here what is bandwidth? Basically, bandwidth is the speed of transmitting speed of the signal over a channel, or how fastly the signal is transmitted over a given channel. So the bandwidth is a 200 Mbps per megabits per second in the 4G. Now the latency. Latency is nothing but this is the propagation delay, or the time taken to a signal that is reaching from the transmitter to receiver. How much time is considering a signal reaching from transmitter to receiver, that is called latency or delay. So the latency is 20 to 30 millisecond in the 4G, and 4G is a 10 times faster than 3G due to this OFDM and MIMO concept, and increasing the bandwidth 200 Mbps, and the RF radio frequency band utilized in the 4G, that is 700 to 2500 megahertz. So the frequency band that is used in the 4G, that is in the megahertz frequency band. But if we discuss about the 5G frequency band, that is in the gigahertz. So next one is the at 1 kilometer square, at 1 square kilometer area coverage region, and the 4G has operated only 4000 devices at a time. Means 4G devices are covered in a square kilometer area. 4G has covered 4000 devices are in a square kilometer area. And if we talk about the 5G, that covers 1 million devices in the same square kilometer area as comparison with 4G. And the average speed of a 4G, that is 25 megabit per second due to this some OFDM and MIMO techniques. So this all about the 4G, and let's move to the next slide, that is the 5G and its some components. So here we will discuss the 5G, and we also compare this 5G component with 4G. So 5G is nothing but this is a new radio technology, and it improve the 4G services and also implement some new technologies in the 5G. 5G is the 5th generation mobile network communication system. Some components of the 5G are the 5G, the frequency band, RF band is in the gigahertz frequency band, that is 30 to 300 gigahertz. So if we take an example to understand this frequency band, suppose there is an one-way road and a lot of vehicles are moving on that one-way road. So due to the maximum number of the vehicles, there is a lot of traffic on the single-way road. So if we replace the one-way road to two-way or four-way, then for same vehicles, then all the vehicles are divided in the different paths, so the traffic is reduced. So same method is implemented on this 5G RF band. So the maximum number of the devices that creates the traffic that are divided in the large band 30 to 300 gigahertz. So due to that they are freely and flexibly assessed the data rates and communication establishing the communication link between the base stations and users. So next one is the latency. Latency I have already discussed in the back slide, that is the propagation delay, that is less than 10 millisecond in the 5G, but in the 4G this is the 20 to 30 millisecond. In the 4G this is the large, but in the 5G this is small. So this is capable for fast action things, where suppose automatical driving cars, self-driving cars, this less latency is capable for that, very useful for self-driving cars. Next one is a millimeter wave. The 5G is the millimeter wave system. The signal of the 5G is traveling for some millimeter distance, due to if as we all know If the wavelength is small, then frequency is large, or if the frequency is large, wavelength is small. Here the frequency is the gigahertz, so the antenna wavelength is very small, so it travels some millimeter distance but with high frequency, so that is called millimeter wave system. Next one is, in the same coverage area it operates the more number of devices as compared to the 4G. As we have already discussed, in the 4G there are the 4000 devices are operated in the square kilometer area, but in the 5G it operates about the 1 billion devices in the square kilometer area. So this is the very big difference between them and very big achievement in the 5G. It operates the more number of the users than 5G with gigahertz band. So next one is, it improves the capacity and data rates due to this massive MIMO and beamforming. It uses the massive MIMO system, massive number of the multiple input and multiple output system. Means on the base stations it has mounted the large number of the antennas, large number of the transceivers, multiple input and multiple output. So multiple number of the users are communicating with a multiple number of the transceivers on the base station in uplink and downlink. So due to this massive MIMO system, here in the 5G there are the 256 to 512 antennas are mounted on the base stations that are responsible for serving their users in the coverage region for some millimeter wave distance. So due to that, the improve the data rates and improve the signal strength, improve the capacity of the system. And the beam forming, next one is the beam forming is a technique for forming a beam in a particular direction to serving their user. Basically beam forming, if we try to understand this, beam forming is a technique when there is any user sends the communication request to the base station. So base station, what base station do? Base stations only sends, firstly base station sends the request, and then it transmit all the power in the requested users, focus to the requested users for serving only that particular users on the requested users directions, or it transmit all the power to the some particular users in particular direction to serving their users. So this is the beam forming technique. And beam forming, in the beam forming it reduce the extra power consumptions that is before the 4G, before the 5G techniques are used. So if the base stations transmit the power in all the directions, and sometimes all the users are not are communicating, and then that power are extra wastage of power. So beam forming is a technique that reduces the extra power consumptions. That is called the beam forming technique. So the bandwidth that is used in the 5G or considered in the 5G, that is the 800 megahertz, but as compared to the 4G, in the 4G the bandwidth is 200 megahertz, but in the 5G that is 800 megahertz. So this all about the 5G, and we have compared with 5G to 4G. In the 4G the band is 700 to 2500 megahertz band, but in the 5G this is 30 to 300 gigahertz band. So latency in the 5G is less than 10 millisecond, but in the 4G that is 20 to 30 millisecond. The 4G is the kilometer, the 4G waves are transmitted over a kilometer distance, but in the 5G this is a millimeter wave distance. The wavelength of the 4G is greater than 5G, but in the 5G wavelength is lesser than 4G. So the frequency range of the 4G is less than 5G, but the frequency band of the 5G is greater than 4G. So the on the same coverage area 5G has operated the large number of the users, about 1 million users, but in the 4G in same square kilometer area has operated on the 4,000 devices only. So 5G use the massive MIMO concept, 4G use the MIMO concept only, and these type of things. So this all about the 4G and 5G. So that's all for today lecture. Thank you guys. If you really something understand from this video, so please subscribe my channel, like, share and comment. So thank you guys.